The C929, China's fully self-developed long-range wide-body aircraft, has just hit an astonishing milestone, one that signals a new chapter for the global aviation industry. What was once only a concept has now transformed into a massive leap forward. It's a bold declaration that China is ready to reshape the world's aviation landscape and stand toe-to-toe with long-established giants like Boeing and Airbus. So just how capable is the C929? How have Airbus and Boeing reacted? Let's break that down, starting with the basics. What kind of aircraft is the C929? After the C919 officially entered commercial service, China immediately turned toward a far more ambitious goal, building a wide-body aircraft using fully independent technology. The C929 is a long-range, twin-aisle jet designed to carry around 280 passengers across distances up to 12,000 kilometers. This places it directly against two of the world's most iconic long-range jets, the Boeing 787 and the Airbus A350. The project began back in 2015, when China's experience with wide-body aircraft was still relatively limited. To accelerate development, COMAC partnered with Russia's United Aircraft Corporation, or UAC. Together, they invested more than $2 billion to create a new aircraft originally called the CR929. According to the early deal, China would fund development, Russia would contribute technical expertise, and final assembly would happen in China. The primary markets would be China, Russia, and Asia. At first, the partnership seemed perfect. China offered large-scale manufacturing capability and strong supply chain management, while Russia contributed its strengths in materials science, aerodynamics, and engine technology. But everything changed after the outbreak of the Ukraine conflict in 2021. Russian engineers were reassigned to military projects, delaying progress on the CR929. While China had completed most of its assigned tasks, Russia failed to meet its commitments. Rumors also spread that the partnership broke down because China wanted access to Russia's engine technology, something Moscow was unwilling to hand over. In 2022, Russia officially withdrew from the program. After Russia stepped away, China renamed the aircraft the C929 and continued development independently. Although Russia still provides a few components, nearly all design and production responsibilities now rest with China. Many questioned whether China could finish a wide-body jet that meets global standards without Russian assistance, especially considering how complex such aircraft are. But China surprised observers by announcing major progress. On February 20, 2025, COMAC revealed that the C929 had officially entered its flight testing phase. This wide-body jet was designed to international certification standards and holds completely independent intellectual property rights, a major breakthrough for China's aviation industry. Soon after, Western analysts reported that Boeing and Airbus would now face a serious new challenger, backed by an industrial superpower. This is not merely a technical milestone. It represents China's broader goal of becoming a leading global aviation player, equal to the United States and Europe. So how powerful is the C929 really? And why has it captured so much attention? How powerful is the C929? At first, many assumed the C929 was just a larger C919, a narrow-body aircraft built mainly for domestic flights. But once the technical specs were released, experts quickly changed their views. The C929 seats roughly 280 passengers and flies up to 12,000 kilometers, triple the range of the C919 and nearly double its capacity. Unlike the C919's single-aisle design, the C929 is a wide-body twin-aisle jet built for ultra-long routes like Beijing to New York or Shanghai to London. Most importantly, it aims directly at the Boeing 787 and Airbus A350, and in several areas, the C929 actually stands out. First, the aircraft uses 10 core systems, including advanced avionics, communication and navigation systems, primary and secondary hydraulics, and a next-generation wing design. These improve performance, safety, and overall operating efficiency. Second, its use of materials is a major highlight. The jet incorporates about 15% titanium, similar to the Boeing 787, and over 50% carbon fiber composites, more than 4 times the amount used in the C919. This improves strength, cuts weight, and reduces emissions, aligning with the global push for greener aviation. Built upon the international certification framework established during the C919 program, the C929 is manufactured with exceptionally tight tolerances. It consists of over 2.2 million individual components and has already undergone more than 3,500 test procedures. It also features a real-time monitoring system that tracks the aircraft's status throughout flight, something not all current jets have fully implemented. Third, the cockpit combines modern avionics with adjustable seating, smart lighting, and a modular cabin layout. Of the 9 avionics suppliers involved, 4 are Chinese, showing the country's rising mastery of aviation tech. Shanghai Aircraft Corporation, in particular, plays a major role. The C929's wingspan reaches nearly 65 meters, wider than the Boeing 787, requiring cutting-edge aerodynamic and structural design. The cabin width is also noteworthy at 5.5 meters, wider than both the Boeing 787 and Airbus A350, offering passengers a more comfortable long-haul experience. Finally, China plans to use competitive pricing as a powerful tool against Boeing and Airbus. With a track record of delivering solid quality at lower cost, China intends to gradually carve out a share of the global market, and the C929 is central to that strategy. The CJ2000 engine. One of the most important milestones of the C929 is its domestically developed CJ2000 engine. Previously, China's aviation industry faced pressure from Western restrictions, especially during the development of the C919, which had about 60% domestic content but still relied on an engine jointly developed by the United States and France. With the C929, however, China aims to gain full control over its propulsion systems. The CJ2000 was originally meant for the C919, but concerns about certification delayed its application. Instead, the C929 will serve as the primary testing platform, with engine flight tests planned for 2029. If successful, this will be a landmark achievement, allowing China to finally break free from dependence on Western engine technology. The CJ2000 generates up to 35 tons of thrust, matching some of the most advanced engines in the world. It has improved fuel efficiency, lower operating costs, quieter performance, and better passenger comfort. With a fan diameter of 3 meters and a total height of 4.55 meters, the CJ2000 is even larger than the GEnx engine used by the Boeing 787. Its cruise phase fuel consumption is lower than many international competitors, helping make the C929 one of the most cost-efficient wide-body aircraft now emerging. It can reach speeds near 980 kilometers per hour, flying smoothly with reduced noise, giving it an edge over both the Dreamliner and the A350. Because of these technological advancements, the C929 is more than just another aircraft. It represents China's strategic leap into becoming a global aviation power. Western analysts acknowledge it as a direct competitor to the Boeing 787 and Airbus A350. With high domestic content and a flood of new innovations, it's a development the West can no longer overlook. China's aviation industry is rapidly rising and establishing itself globally. Recently, the regional ARJ-21 aircraft was renamed the C-99, showing progress toward a mature domestic aviation ecosystem. Once the C929 enters commercial service, China will essentially complete its own civil aviation lineup and reduce its dependence on the West. But China isn't stopping there. After the C929, the country is exploring even larger and more advanced aircraft like the C939 and C949, which could eventually challenge jets like the Boeing 777X and Airbus A380. COMAC even announced plans for a supersonic aircraft, the C949, which could be launched around 2049. This concept includes a double-deck, triple-aisle layout and a brand-new supersonic airframe, potentially reshaping global aviation if successful. Sources also claim that early designs for the C939 have already been drafted, marking a crucial step toward the next generation of wide-body jets. Of course, turning blueprints into a functional prototype is a long, difficult process, but China now has a firm foundation to pursue these goals. Today, China is the world's second-largest economy with one of the fastest-growing aviation markets. Over the next 2 decades, COMAC predicts that China will need at least 9,000 new aircraft, with around 1,000 being wide-body jets. If China continues relying on Boeing and Airbus, it will face rising costs and potential restrictions from Western technology policies. So, building a fully independent aviation industry isn't just a goal, it's a necessity. With the C919 in service, the C929 entering flight tests, and the C939 already under development, China is constructing a complete aviation ecosystem. Developing aircraft is incredibly complex, from design to testing, certification, mass production, maintenance, and customer support. Every stage demands deep technical capability and a reliable supply chain. But China is advancing steadily, proving it has what it takes to climb to the top of the aviation world. If the C929 completes its flight testing campaign successfully, it will send a clear message. China is no longer just a manufacturing powerhouse, it is becoming an aerospace superpower. And this is only the beginning. In the next decade, even larger, faster, and more advanced aircraft like the C939 and C949 may become reality, pushing China deeper into the global aviation race against Boeing and Airbus.